So hello. Today I'd like to talk about something that forms the basis of mechanics. It's displacement and distance. How they're similar and how they're different. Now we're mostly familiar with distance, but displacement is the new term. We'll see what the difference is between them. So I'm going to think about maybe a ball, just at a certain position. Let's call that position A. That's the starting position that the ball is, and it's not really interesting when it's moving. It's a lot more interesting when the ball starts to move. So let's say that the ball moves 10 meters to the front, like here. That it moves 10 meters, and it's right there now. It's the ball. It's now 10 meters ahead. The distance is the path that it has traveled over, or it has rolled over. So it has rolled over this distance of 10 meters. And then the displacement will be how far away it is from this starting point. So it has rolled over a distance of 10 meters, and it's also 10 meters away from the starting point. Well, what if it rolls a little further? It rolls another 3 meters, maybe. Now it's here. There's the ball. Well, how far is it from the starting point? It's now 10 plus 3 meters away from the starting point. That's 13 meters. That's the displacement. How far away it is from where it started out. 13 meters from the beginning. What's the distance? Well, we look at and think about how far has the ball rolled. It has rolled also 13 meters. Well, the difference might not be so clear now, but it gets more interesting when the ball starts moving backwards. So let's say that this ball, now there's someone at this end that kicks it or that gives it a push, and now it moves 8 meters in this direction, in the backward direction. So where is it now? It was 13 meters away from the start, but now it's moving backwards. We can calculate how far it is now. We're doing 13. It's now somewhere right there. We can think about how far it is from the starting point. We can do that by thinking 13 minus 8. 13 minus 8 is actually 5. So 5 plus 8 gives us 13. So what is the distance now, and what is the displacement now? Well, distance, how far has it rolled? Well, it rolled the 13 meters from the start, and then it rolled another 8 meters to get here. So it's actually rolled 10 plus 3 plus 8 meters, which will be 13 plus 8, and that's 21 meters. But what's the displacement? We're going to think about how far is it from where it started out. So it started out right there. And how far is it from that position? It's only 5 meters away from that position. So the displacement here is 5 meters at this position here. Maybe it's position C. That's 5 meters, but the distance that the ball has covered is actually 10, 3 plus 8, which is 21 meters. What if it moves a little further? What if it moves a little more backwards, and now it moves behind the starting position? So we have the same starting position that we had, that position A, and we have the ball starting there, but this time it moves like that. It moves 5 meters in that direction. Well, what distance has the ball rolled over? It has moved 5 meters, so we'll say that the distance is also 5 meters here. But what is the displacement? Well, this is where we're going to introduce something that helps us to understand the difference between distance and displacement. What if we had another ball here that was also 5 meters away, but in the opposite direction? We would say that the displacement is the distance away from the starting point. Well, this ball here is 5 meters from the starting point, and this one here is also 5 meters from the starting point. So what's the difference? That's where I would have to introduce signs. We're going to use a positive sign there and a negative sign there, just to show that here it is 5 meters but backwards, 5 meters before the starting point, and here it's also 5 meters away but 5 meters ahead of the starting point. And so the distance covered in both these situations, to get from there to there, it rolled 5 meters, and to get from there to there, it also rolled 5 meters, but here it rolled 5 meters backwards. So when the ball is here, the displacement will be negative 5 meters. It's describing the position, while here it will be positive 5 meters. It's something like that. What if the ball that's here at negative 5 meters now moves forwards? It moves forwards a distance of 12 meters. Well, we can see how far it is now from the starting point. Let me just remove some of this stuff. Let me just get this out. So it rolled backwards first, 5 meters backwards, and now it rolled 12 meters to the front. Well, we can calculate this distance, how far it is from the starting point now. Just going to have to do 12 or minus 5 plus 12, and that gives us 7 meters. So this distance is 7 meters. That's 7, that's 5. So how far did it roll to get here to maybe position D, from position A to position D? Well, it rolled 5 meters, that was 5 meters, then it turned around and rolled another 12 meters. So we're not going to take this as a negative, we're just going to say it rolled 5 meters, then it rolled another 12 meters, which will be 17 meters. So it has covered a total distance of 17 meters. But what's the displacement? Well, the ball is right here. The displacement will be how far away it is from the starting point. How far is it? It's just positive 7 meters from the starting point. And that's the difference between distance and displacement.